topic 5.13, how do we reduce urban runoff? So we have to figure out in this episode ways to mitigate, make less damaging. That's a synonym for alleviate. Reduce the effects, the negative effects of the urban runoff. And as we can see right here in this photograph, we have all this oil leaking in the rainwater and then going here. And at least in most cities, especially on the West Coast, this all goes into the ocean. There are some cities on the East Coast usually that still filter, or they put their wastewater through a wastewater treatment plant. The problem is when it rains a lot, usually it overflows and the wastewater along with this goes into the ocean or the river or wherever they're at. So this is the LA River that you are used to seeing whenever you cross Artesia. Go to DeForest Park, walk along it. You'll see the center channel. It's about 3 to 4, actually I think feet deep. I believe probably across it's about 7 to 8 feet. So not that much water, and most of this is treated wastewater, which is not in itself a bad thing, because as you know, treated wastewater is pretty darn good water now when it's out in the channel and other runoff from the street is going into it. Definitely not drinkable in that situation. Lo and behold, this is what the LA River turns into several times a year depending on rainfall. I mean, check out the waves. Wow, you could like surf that. I also encourage you, when you're out, if you go to DeForest Park or if you're along the LA River, always kind of look at the top little debris line. Just kind of look at where the branches and sticks are, other debris, flotsam and jetsam. And it shows you how high that water can get. This is extremely dangerous. I see it looks like the center channel be somewhere right there. But this is all urban runoff, and remember, this is water that's carrying whatever kind of gunk is on the street. It's going to wash into the LA River. And this is the LA River down by probably Wardlow, something like that. We see all this trash. Wow. This all came from the streets, right? People just, the garbage, not getting the garbage. So in all of this stuff, oil, trash, chip bags. Half of this probably chip bags. Then drink cups. But you have other things, fertilizers, brake dust, that kind of stuff you see on the wheels. You get to clean off. That's all over the roads, and that all gets washed in. That's not good. Some of that, if you used to have asbestos in it, it's not good stuff. And dog, there's a lot of feces from dogs. People don't pick up after their pets. So yuck. We want to figure out ways to mitigate this happening right here. So, this is kind of a rundown right here. Really, we want more infiltration. Remember, that means soaking into the ground. Going into the dirt, going down, making mud, hopefully reestablishing our groundwater. So this is being done right now quite a bit. On campus, we have this new kind of pavement, at least in one parking lot. Basically, it's permeable, so the water can soak through. So permeable pavement, planting more trees, increasing use of public transportation so you have less gunk and filth on the street, and building up, not out. So if we can take up less land, right? When we take over the land, we make it hard. We make it impermeable. So urban sprawl equals impermeable surfaces. We want to make them permeable. But so if we live in higher density housing, high rises, multiple family homes, we can help to alleviate the impacts of runoff. So this, hopefully you've gotten over to Forest Park. They just developed these wetlands, I believe 7-8 years ago. So this is the Forest Park wetlands. This used to be kind of just a bunch of trees, but you can see this is the LA River over here, right over that little hump, and it kind of, the elevation goes down and over, and what this catches is overflow from the river, goes, instead of just into the ocean, comes into the Forest Park wetlands, where it can soak into the ground, where it can get naturally cleansed, and it can provide habitat for birds, and it provides a beautiful place for us to go and walk. Officially, these can be called retention basins and detention ponds. So this is another type of retention basin. These are all throughout the LA area. Retention and detention. Okay, this is like basically a big pond. Put that water over here, and it can be more useful, and this will helps recharge groundwater. And we know during droughts we rely more heavily on groundwater. So if we can get more of that groundwater, that's great. And this is ecosystem support, right? Support ecosystems, keep them healthy, keep them sustainable. All the birds, all plants, everything working together here. It's a beautiful thing. So go over to Forest Park Wetland, definitely check that out. Most cities, they're being more cognizant of that. So pervious and impervious surfaces, you'll see this is the urban environment. You have a lot of surface flow, which is going to go not into the ground but into a river and then somewhere else. Not a lot of subsurface flow. Now you see impervious surfaces, not a whole lot of development. You see more of that water getting down into the subsurface. You see less runoff, right? So just less runoff. And this is not the fairest comparison because this looks like a forest basically, right? Definitely going to be more pervious. So more runoff with these impervious surfaces. A metro area like LA, it can be 40 to 70% impervious. So we want to get that percent down as low as possible, depending on the neighborhood. But that's kind of the general rule. And right here these are 4 different types of permeable pavements, pavement types. So permeable pavement types. These are 2 kinds of asphalt that can soak water through. And down here, these are pavers, interlocking pavers. You'll see there's, cracks in the middle that help slow the water down. So slowing the water down is key. The water picks up less if it's going slowly. So to slow that water down. Slow down. And you can see you can have interlocking. These are interlocking too, but you have plants. They're actively growing plants right there. That looks nice, right? So it's a little more expensive, you know, put down those pavers. But with government incentives, then the government subsidizes almost everything. You know, we could do that. So here's, you'll see there's basically grass and trees growing on the roofs. These are called green roofs. Okay, in gardens. And you can see this absorbs the runoff. There's going to be less runoff because of these. So less runoff. You know, captures the rainfall. And that's just the runoff benefits. The other benefits are this helps to keep the building cool, helps stabilize it so it doesn't have to run as much heating and cooling, and keeps the air temperature around the area cooler with all these plants doing evapotranspiration, releasing heat to the atmosphere. So this is just a great thing to do, but you know, kind of probably on the expensive side. This is a rain barrel. So basically you set up a barrel. It's easy to do. You just put your downspout from your gutter down into the barrel, and you can use this water for watering the garden, doing doing everyday things around the yard, and you know, whatever you want to. But the problem is these are usually against plumbing codes to have this. Against. Gosh, let me just try that again. Let me see. Let's see. Violate plumbing codes. A lot of times. Violate plumbing codes. I think the main reason is if everybody had, you know, big, huge tanks of water right next to their property, you know, what if that water breaks or leaks out? It could spill over to the neighbor's property, and that can cause more problems. So, but we can change laws. I mean, if we go into a super drought, I mean, we're going to have to do something, right? And we could have incentives. Like tax breaks, other subsidies, government subsidies. Okay, so having the government support this to help alleviate, we're going to pay for it one way or another. Either collect more water, or our water is going to be more expensive. Rebates is another way to do it. Maybe you've heard of a rebate. If you install it, the government can pay you back for some of it. And this also this helps prevent water loss, but you know, this prevents that water from going into the street and then washing the pollutants all over the place. Again, you know, trees, urban trees are always great. They function in so many ways. But here, if you have all the trees, you're just going to have more permeable, you're going to have more infiltration. Urban trees increase infiltration. Infiltration. Okay, more of that water gets into the ground. So many benefits. Keeps that water clean. So at the end of the day, you know, we have a major issue. This is down Bayshore right here after a storm. You just got trash everywhere. So it really affects us a lot because we have so many impermeable surfaces here in Southern California. Our wastewater runs right into the ocean. We all appreciate the ocean, going to the beach, keeping it clean. So we can have some nature-based solution if we just get rid of hardscape, or we can put more permeable pavement in, change the way the architecture works with those green roofs that we talked about. So this is something that's doable. It's going to make our environment better. So a suggested skill AP wants for this would be to do a scientific experiment somehow. So we could set up, we could get samples of asphalt. We could get pervious and impervious or porous. Let's just use what they got. What I put on the picture here. Porous. I think porous and non-porous asphalt versus normal. So normal, kind of that's your control, right? So you could have, this is the porous asphalt. You could have a chunk normal right here. And you can pour water on here. Say you pour 500 milliliters. You could measure the water that falls through in a certain amount of time. You measure it for like 30 seconds. Get like, a milliliter. Let me write that again. You could calculate milliliters per second, milliliters per minute. Go a minute. Milliliters per minute. Say 30 milliliters per minute. So you got 50 milliliters per minute. And then compare that with the normal concrete and then measure how much comes through. And you see it in action over here. I mean, look, this is a big difference. And just so you know, over by the new gym, the parking lot by the new gym has this kind of, so we should go over and do that. Yeah, we'll do that. Parking lot, new gym has permeable concrete. I've seen it in action. You pour water on it, it disappears. It just goes right through. All right, so hope this video helps you understand a little bit more about urban runoff.